All right, so the next thing we're going to do in the unit is we're going to learn how to graph sine and cosine graphs without a calculator. So when we graph, we actually start with the unit circle. So this says sine x equals y, right? Y equals sine x, that's making it a function. But what I'm going to think of is whatever I plug in for x, I have to use my unit circle to evaluate that. So if I start off with 0, then sine of 0 would be the y coordinate, which is 0. So when I graph it, that's going to be the point 0, 0. I could do sine of pi 6, that's 1/2, that's pretty easy to graph. Sine of pi 4ths would be a little bit harder to graph because that's root 2 over 2. Sine of pi 3rds would be pretty hard to graph, root 3 over 2. But sine of pi halves is pretty easy to graph because it's just 1. So the next thing I'm going to plug in is pi halves because that's 1. And then again, I'm going to ignore. Well, this one I could graph. But then over here, I've got sine of pi is 0. All right, and then I'm going to ignore, and then graph this one. So if you notice, I'm picking all the quadrant angles. Quadrantal angles is what they're called, the ones that are actually on the quadrant lines. And the reason I'm doing that is because I'm lazy, and these are the easiest to graph. So 2 pi brings me back to 0. Okay, so what I'm going to do is I'm going to take a marker. The reason I'm going to use a marker for this part is because it's a lot easier to see what you're doing and to like graph on top. So I'm going to use a marker to draw my x-axis and to draw my y-axis. Did I get it in the middle? It kind of looks like it's in the middle. Okay, so I need to be able to graph 0, pi halves, pi, 3 pi halves, and 2 pi. And what I like to do when I graph these is I like to go in sets of 4, and I will show you why. So I'm going to say here's 0. I'm going to count 1, 2, 3, 4. I'm going to put a pi right there. 1, 2, 3, 4, put a 2 pi right there. And then I'll do the same in the opposite direction. Okay. And then we'll say that up here, maybe I'll go by 2. So 1, 2, -1, -2. I could have gone by 1s. It's up to you. Really, it's very important when you graph these that you label how you graphed them, the numbers, because everybody does it a little bit differently, and it would make a difference for how you graph it. Okay, so I've got the point 0, 0. I've got the point 2, 0, and I'm going to show you guys, this is kind of how I graph it when I do a sine graph. So I say it starts at 0 and it ends at 0. And then what you'll notice is it hits 0 in the middle as well. So it starts at 0, ends at 0, hits 0 in the middle. And then between the first 2 points, it goes up to 1. So this is between 0 and pi at pi halves. It goes up to 1. And between the second 2 points, well, the second 2 zeros, I guess, it dips down to -1. Okay, now this is not a curvy one, or it's not, I always say it doesn't look like Charlie Brown's hat. You know how his hat has those like, it doesn't look like that. These are actually kind of U-shaped, and you can't tell based off the points we chose because we were lazy, but if we had done some of those decimal numbers, if we had done these in between numbers, then we would have been able to tell definitely that it's not doing like a zigzag shape. It's actually doing like a wave kind of shape. Okay, so what I'm going to do is I'm going to draw a second period of the graph. So this is considered to be a full period, right? Because you went around, so it's a full period of the graph. So I'm going to do the same thing. I'm going to count out 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. So I have a 0 at the beginning, I have a 0 at the end, I have a 0 in the middle. And then between the first 2, I'm going to go up to 1. Between the second 2, I'm going to go down to -1. And then I connect it using kind of U-shaped graphs. Okay. And then I can do the same thing this way. I can count 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have a 0 at the beginning and a 0 at the end and a 0 in the middle. Between the first two, I go up to 1. Between the second two, I go down to -1. Okay, and so on. We could keep going if we wanted to. So when, I'm always going to put arrows on either end. So whenever you trace this, your finger should go up and down, up and down, up and down. And it should be a smooth curve. You should be able to kind of look at it and recognize that it's consistent and symmetric and all those beautiful things. Okay, so the amplitude is how far it goes up from the middle or down from the middle. So this one, I'm going to go ahead and label it right here. This is the amplitude. So the parent function, y equals sine x with no transformations happening to it, the parent function has an amplitude of 1. The period of the graph is how far it goes to have a full cycle. It goes up, it goes down, it comes back to the middle. It goes up, it goes down, it comes back to the middle. So a full period of the graph is 2 pi. So we'll go ahead and label that. This right here is the period of the graph. Okay. The domain is the x values we can use. You'll notice that it has a left arrow, it has a right arrow, it uses all of them. So domain is -infinity to infinity. The range is limited though. This doesn't go up forever, it doesn't go down forever. It actually bounces back and forth between two values, and that's -1 to 1. It bounces between those. So range is -1 to 1. Okay. So let's go ahead and look at the transformations we have. We're going to say, here's the parent function, y equals a sine. And then I think we can just use b. I think that's what I've used in the past. I'm going to go ahead and use an h and a k even though we don't really have a vertex for these graphs, just to kind of throw it back to what we did before because it actually, the transformations kind of come from the same place. So the number in the front, we are used to saying that it has a stretch or a compression and that it tells us if it reflects, which is still true, but we don't call it a stretch or compression anymore. We call it an amplitude. So this A right here is going to tell us the amplitude of the graph, and the amplitude is always positive. It's always going to go up and come down, but it's how far it goes up and comes down. So the amplitude is telling you a distance, and that's why it's always positive, okay? So amplitude, I'm going to write, is the absolute value of A, always. If A is negative, then instead of going up first, you're going to go down first, okay? So if A is less than 0, then reflect. Okay. This number right here, we've never had one before, right there. That number right there is a period change for the graph. So a normal period for the graph is 2 pi. To figure out the period, if we have a number there, we're going to do 2 pi divided by b. So if you have 2 in front of the x, then the period of the graph would be 2 pi divided by 2, and then you would have a full period, so it would go up and come down, and it would be squished in right here instead of this whole width. And then this number goes left and right, just like you are used to saying, and then this number goes up and down, just like we're used to saying. Okay, so if we look at the first example, it looks pretty normal, except it has a 2x, right? And if we put parentheses, they'd be right here. Okay, so it has a 2x, so that means the amplitude is going to be 1. The period of the graph is going to be 2 pi divided by 2, so the period of the graph is just pi. Okay, so I'm going to go ahead and start off by drawing the x and the y, just like I did before. Okay, and I'm going to go ahead and count 8 boxes, just like I did before. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go, so I went ahead and I did my intervals exactly the same as the previous problem. But I just have to be careful now because instead of starting at 0 and ending at 2 pi for the period, it's going to start at 0 and end at pi for the period. So now I'm going to do the rest of it the same. I'm going to say, okay, starts at 0, ends at 0, it touches 0 in the middle. And then between the first 2 points, I'm going to jump up to 1. Between the second 2 points, I'm going to jump down to -1. Okay, then I'm going to connect it. I'm going to make sure that looks like a U-shaped graph. And then I can do the same thing again. So count the same number of boxes. This time it happens to be 4. So 0 at the beginning and the end, 0 in the middle. Between the first 2, it goes up. Between the second 2, it goes down. Count 4 boxes. 0 in the middle. Between the first 2, it goes up to 1. Between the second 2, it goes down. Okay, and then again, I'm going to just make sure I have my arrows. So you know you've done it right, like I said before, when you can trace it with your finger and it repeats the pattern, your finger never stutters. You'll notice you did it wrong if you have a hard time following it because it means you did loops in the opposite direction of what you should have. And when you look at it with your eye, it should feel very symmetrical. It should feel like a nice smooth curve when you look at it. All right, so the domain for this graph, it goes left forever, it goes right forever. And then the range, it bounces between -1 and 1. Okay, go ahead and flip your notes over. So this one, they're adding a little bit more to it. This time there's a negative in the front. So that means that this graph is going to be reflected over the x-axis. Okay, but it still has an amplitude of 1 because we're going to do the absolute value of -1, which is just 1. So that means it hasn't been stretched or compressed yet. We're doing an amplitude of 1, which is normal for these graphs. Normal period is 2 pi. We're going to be dividing it by 3, and so the period of this graph is 2 pi thirds. And before you get freaked out about it being in terms of thirds, don't worry, because we're still going to work with the 4 boxes like we've done each time. Okay, so I'm going to go ahead and draw my axes. Okay, so, and again, I'm going to do exactly what I did before, and I'm going to count 8 boxes. I'm going to do 1, 2, 3, 4. I'm going to mark that 5, 6, 7, 8. Now, we saw before that since we take something and we cut it in the middle and then we do the middle again, it works best to have your number of boxes be in sets of 4. So I could do 2 pi thirds right here, or I could do 2 pi thirds right here. It doesn't matter. I could even count 12 boxes and do 2 pi thirds over there. As long as you have something in sets of 4, it makes it pretty easy to graph. So I'm going to go ahead and just do my 2 pi thirds right here. And so that means that half of 2 pi thirds would be 1 pi third. That means pi thirds is right there. So just like before, I'm going to say I start at 0 and I end at whatever the number of the period is. So the period is 2 pi thirds, so that's where I end. Okay, so start at 0, end at 0, 0 in the middle. And I can't draw anything else because I didn't do any more labels. Let me go ahead and finish those labels. And so normally between the first 2 points we would bounce up to 1, but this graph has been reflected over the x-axis. So instead of bouncing up to 1, we're going to bounce down to -1. And then normally with these 2 points we would go down to -1, but since we've been reflected, we're actually going to go up to 1 instead. Okay. And then we're going to do the same thing again. So we did 8 boxes for the entire period. So we're going to count 8 boxes again. 1, 2, 3, 4, 5, 6, 7, 8. So it starts at 0, it ends at 0, it touches 0 in the middle. And then between the first 2 points, we're going to bounce down to -1. Between the second 2, we're going to go up. And then I'm going to make sure that I put arrows on either end because it continues. So the domain for this graph is going to be negative infinity to infinity again. And the range is going to be from negative 1 to 1. Okay, so next they have a little bit more in terms of the transformations for us. So we have a negative 2 in the front, so the absolute value of negative 2 is positive 2. So this graph is going to have an amplitude of 2. It says x divided by 2, so we're going to have a 2 pi. And if I was to rewrite this, I'm going to go ahead and write it maybe the way that you guys are going to need to think of it, like this. Okay, so maybe that will clear it up a little bit. So x divided by 2 is the same thing as saying like 1/2 x. So I'm going to say 2 pi divided by 1/2. And then I'm going to go ahead and say keep it, change it, flip it. And so the period of the graph is actually 4 pi. All right, so we have this graph is being reflected over x. It's going to have an amplitude of 2, so it's going to be taller than it was before, and the whole graph needs to be shifted up 1. Okay, so I'm going to go ahead and draw my axes like I did before. Okay, and we are still doing sets of 8 boxes just like we did before, so 1, 2, 3, 4, 5, 6, 7, 8. So maybe I'll say that this is 4 pi. And so that makes these 2 pi. Now, to make sure I have enough space to do an amplitude of 2, so it's going to be up 2, down 2, and to be able to take the entire graph and shift it up 1, I'm going to have to go by ones this time. So 2, 4, negative 2, negative 4. All right. Special trick that we're going to do anytime we have a shift, left or right or up or down. So what I'm going to do, this is a shift of up 1. So what I'm going to do is I'm just going to draw a line at up 1. Okay, and what I'm going to do now is I'm okay, so I'm going to start at 0. I'm going to end at 4 pi. I'm going to hit the 2 pi in the middle. And then it has an amplitude of 2, so but it's got a negative in the front. It's reflected over x. So between the first 2 points, we would normally go up 1, but instead we're going to go down. And since it's got that amplitude of 2, instead of going down 1, we're going to go down 2. So go down 2. Between the second 2, normally we would go down 1, but it's been reflected, so we're going to go up instead. It has an amplitude of 2, so we're going to go up 2. Okay, so start, count 8, start and end at 0, hit 0 in the middle. Between the first 2, go down 2 because of that amplitude. Between the second 2, go up 2. And there's what your graph looks like. And you can see that if I were to trace it with my finger, it's a very consistent, smooth, there's symmetry there. So here the domain would be from negative infinity to infinity. And the range is a little bit more interesting this time. It goes from negative 1 up to 3. All right, this video is long enough, so I'll save the last one for when we come back.